Before we talk about integer exponents, let's look at the pattern with some whole number positive exponents. What I've shown here is that 2 to the 4th power equals 16. We know 2 to the 3rd is 8. 2 squared is 4. And 2, or 2 to the 1st power, is just 2. Notice how I've listed these so that the exponent comes down one number each time. 4, 3, 2, 1. I want us to look at the pattern in the value of the answer here. 16, 8, 4, and 2 decreases by a power of 2. 16 divided by 2 gives us 8, divided by 2 gives us 4, divided by 2 gives us 2. It's this pattern that helps us see how integer exponents, which means the negative number exponents, get their rules. If we were to come down one more number on my exponent, I started with 4, 3, 2, 1, so the next number would be, let's take 2 to the 0 power. Let's try to figure out what that is. Well, if we follow this same pattern and divide by 2 each time, since 2 to the 1st was 2, if I take this and divide it by 2, 2 divided by 2 tells me that 2 to the 0 power should be 1, which seems very odd. We'll come back to that one. Let's go back and do another one. Let's take, instead of an exponent of 0, let's go one number smaller and look at the value of 2 with an exponent of negative 1. If we follow the pattern on the right side of my equal sign, I should take the value I got before and divide it by 2. So 1 divided by 2 is a decimal, but we're going to leave it as a fraction for this example and show 1/2. The next number to consider would be 2 to the negative 2. Well, if I take 1/2 and I divide it by 2, 1/2 divided by 2 gets me the fraction 1/4. Negative exponents have absolutely nothing to do with a negative number. Notice my fraction 1/2 and my fraction 1/4 are still positive values. What the negative exponent shows us is that we need some other rules here to evaluate these. Let's go back to the exponent of 0 and write that rule. Written using algebra language, we'll say that a to the 0 equals 1. What this means is that for any a, for any number that you could come up with to the 0 power, the value is going to be 1. And the reason is for the same reason I was showing you with the 2 before. With one exception here, and that's 0 to the 0 power. We consider that to be undefined. So for any a other than 0, every time you see an exponent of 0, the value is 1. Now let's look at the rules for our negative exponents. Let's take an a, and let's say that the exponent here is a negative n. Any base a raised to a negative number is equal to 1 over that base to that positive value. My a as my base stays the same. My n as my exponent stays the same. What changes is, in order to remove the negative in front of the exponent, I have to move this value to an underside of a fraction, showing it as a division. What if the value was already in a fraction? What if I had 1 over a to the negative n? It was already in a fraction. What I do is I move it to the other side of the fraction. Here being on the bottom, I'm going to move it up on top, and I will have a to a positive n. I could put that over 1, but it's still the same thing as a to the n. So what we do when we see a negative exponent is that we move it to the other side of the fraction and make the exponent positive. Let's look at another example then. Let's say that I have x to the negative 3 over y to the negative 4. If I want to make this problem so that it has positive exponents only, what I need to do is rearrange my values that have a negative exponent, like this negative 4 would have to come up on top, and this negative 3 would have to come down here. So then I'll have x to a positive 3, y to a positive 4. In the example, x squared y to the negative 4th over x to the negative 5 y to the 3rd. Notice that not every one of my exponents is positive. I have 2 positive exponents, 2 negative exponents. I'm going to go through and look at this one base at a time. The x squared has a positive 2. I do not need to move it. I do not need to make the exponent positive because it's already positive. However, this y to the negative 4th, that has a negative 4, so I need to bring that to the other side of the fraction and make that 4 positive. X to a negative 5 has a negative exponent, so I'm going to move this to the other side of the fraction. Since it's on the bottom, I'm going to move it up to the top as an x to the 5th. Y to the 3rd has a positive exponent, so it can stay where it is on the bottom. Now what I have is x squared times x to the 5th on top. So I could simplify that and say I have x to the 7th on top. I have y to the 4th and y to the 3rd on the bottom, so I can simplify that to say x to the 7th over y to the 7th. You're not completely done with any of these problems until you get to the point where all of your exponents are positive and none of your exponents are 0.